Hello, my name is Bella Capone, and I will be completing problem number 25 in our Jean Coley textbook. It's on page 40 and in section 2.5 and 2.6, which is motion at a constant acceleration. The problem reads, a car slows down uniformly from a speed of 21 meters per second to rest in 6 seconds. How far did the car travel in this time? Reading the problem, we see that we're looking for our delta x, but we are given some information that we can write down before we choose an equation to solve with. So we know that velocity original equals 21 meters per second. We know that velocity final is 0 because we're coming to a stop. We are skidding to a stop. We know our time is 6 seconds. And we're trying to find our delta x. So looking at our variables, we have velocity original, velocity final, and time. And looking at our equations, I think that using the third equation would be best for us. So velocity final squared equals velocity original squared plus 2a delta x. Now before we fill in what we know, we already see that we have two unknown variables. We have our delta x, which we're solving for, which should be unknown, but we also have acceleration, which we don't know, and we need to solve for that before we can finish the problem or do this equation. So we are going to look at the first equation because we know our velocity final, velocity original, and our time, and we're solving for acceleration. So velocity final equals velocity original plus acceleration times time. So velocity final 0 equals 21 plus acceleration times 6 seconds. Solving for a, we get negative 3.5, which is okay because we're slowing down. And we want to make sure we keep the negative over here. So velocity final is 0 equals 21 squared plus 2a, and a is our negative 3.5. Negative is very important. Times our delta x. Solving for delta x, we get 63 meters. And it is the answer to our problem. Thanks for watching. I hope it helped.